Hello everyone. In continuation to our topic boats and streams, this is the second part. And in that fourth question, a boat takes 90 minutes less to travel 36 miles downstream than to travel the same distance upstream. If the speed of the boat in still water is 10 miles per hour, the speed of the stream is what? So four options are given. We need to choose which one is correct. So first of all, we'll start with speed upstream is nothing but speed of the boat minus speed of the stream. That means speed upstream will be, if the speed of the boat is 10 miles per hour is given, so 10 minus this speed of the stream, we are going to consider it as x. Let s suffix s equal to x. On that basis, we wrote that. Then speed downstream will be speed of the boat plus speed of the stream, which is 10 plus x. Now, we know speed of upstream, speed is nothing but distance by time taken. And let us consider, let time taken upstream equal to small t. We are assuming that. So here, speed upstream, the distance traveled, which is 36 divided by upstream, we are assuming it as t. That means downstream will be 90 minutes less, which means 90 minutes is nothing but 1.5 hours. That is nothing but, I can write 1.5 hours. So here we have 36 divided by t. This will be 90 minutes less. So 36 divided by t minus of 1.5. Okay, so we have now time will be 36 from this first equation. This is first equation, this is second equation. From first, we are arriving at t equal to 36 by 10 minus x. And from second equation, we can arrive t minus 1.5 equal to 36 divided by 10 plus x, which means here t is 36 by 10 plus x plus 1.5. So we can equate those two now. First one is t is equal to 36 by 10 minus 6. So 36 by 10 minus x should be equated to 36 divided by 10 plus x plus 1.5. That can be rewritten as 36. I can take it as common, 1 by 10 minus x. Bringing this to the left-hand side, we get 10 plus x should be equal to 1.5. So this is 36 times. Denominator's LCM is 10 minus x into 10 plus x, which is nothing but 10 square minus x square based on a square minus b square. So here it is 10 plus x minus 10 plus x is equated to 1.5. So that means we can cancel this 10 and 10. We have now 36 times 2x divided by 100 minus x square is equated to 1.5. Now cross multiplying, we will have 72x is equal to 1.5 into 100 is 150 minus 1.5 x square. Multiplying both sides by 10, we get 720x equal to 1500 minus 15x square. Dividing both sides by, can we divide it by 15? 15, 7, 20. 15 fours are 60. 2, 1, 2, 0. 15 eights are, yeah. So we can divide both sides by 15 to get this as 48x equal to 100 minus x square, which will lead to a quadratic equation, x square plus 48x minus 100 equal to 0, which can be splitted, 48x can be splitted as plus 50x minus 2x minus 100 equal to 0. First two terms, x is common, so x plus 50. Second two terms, 2 is common, x plus 50 equal to 0, which means x plus 50 times x minus 2 equal to 0. Ignoring x being your speed, x being our speed of the stream, it cannot take any negative value. So we can say x is equal to 2 kilometer. Sorry, not kilometer here, it is miles in this question. 2 miles per hour. So that is the solution. We will see what is the option. Yes, option A is the right option. Let us move on to the next question. Question 5. A man can row at 5 kilometers per hour in still water if the velocity of current is 1 kilometer per hour and it takes him 1 hour to row to a place and come back. How far is the place? So let the distance to the place equal to x kilometer. Now we have speed downstream is equal to speed of the boat plus speed of the current. So that is equal to speed of the boat is given as 5 kilometer per hour. Speed of the current is given as 1 kilometer per hour. So totally it is 6 kilometer per hour. That is speed downstream. Speed upstream will be speed of the boat minus speed of the current, which is 5 minus 1. So we get 4 kilometer per hour. Now, given the total time equal to 1 hour, that can be equated with time for downstream and upstream. Distance traveled is x kilometer, downstream speed is 6, and then again x kilometer traveled for upstream, speed is 4 kilometer. So this here, x is common. We can take LCM for 6 and 4 as 12. So you get to 2, here you get 3. So that is 5x by 12, which means cross multiplying 12 by 5 is equated to x, which will work out to 5 2s are 10, 4s are. So x is 2.4 kilometer. That means our option A is the right option. Let us move on to the next question. Question 6. A boat covers a certain distance downstream in 1 hour while it comes back in 1.5 hours. If the speed of the stream be 3 kilometers per hour, what is the speed of the boat in still water? Let the speed of the boat in still water equal to x kilometer per hour. Now, speed downstream is equal to speed of the boat, which is x, plus speed of the stream is given as 3. So this is x plus 3 kilometer per hour. Now speed upstream will be speed of the boat minus speed of the stream, which is 3. So x minus 3 kilometer per hour. Now distance traveled upstream and distance traveled downstream are the same. So distance upstream can be equated to distance downstream. Now we know that speed is distance by time, which means distance is speed into time. Using that, let us do this. Distance upstream will be speed, that is SU, speed upstream, multiplied by the time. Time given is downstream it is 1 hour, upstream it is 1.5 hours. So 1.5 is equal to speed downstream into 1 hour. So speed upstream is x minus 3 times 1.5. Speed downstream is x plus 3 into 1. So this can be simplified as 1.5x minus 4.5 is equal to x plus 3. Now bringing all x terms to one side, we get 1.5x minus x equal to 3 plus 4.5, which is 7.5, which means 1.5 minus 1 is 0.5, x equal to 7.5. So which means x is equal to 7.5 by 0.5. Multiplying numerator and denominator by 10, we get 75 by 5, which is 15. So what is that? X is nothing but speed of the boat in still water. So 15 kilometer per hour. So our option is option D. That is the right option.